Hey there! Tonight we're setting off on a journey through the solar system, the vast swirling family of worlds, rocks, ice, and sunlight you call home. You might think you know it well. That bright star up there, those few planets you memorized for school, maybe the occasional comet that gets everyone outside at 3 a.m. But tonight, you're not just learning, you're floating. You're stepping out of your bed, softly, into the slow spin of cosmic dawn, back to the moment our solar system was born. Before we drift too far, here's a tiny reality check. If you'd actually been here when this all started, say 4.5 billion years ago, you wouldn't have survived a nanosecond. Space was a violent construction site, all molten metal, roaring collisions, and radiation tantrums. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop your location and your local time in the comments. It's always beautiful seeing where in the world this sleepy little community is listening from. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're floating in a glowing fog of stardust. The sun doesn't exist, yet only a collapsing cloud of hydrogen and helium, twisting in on itself under the quiet tyranny of gravity. Tiny grains of silicate dust collide, stick, and grow. It's not romantic, more like a cosmic slow cooker set to chaos. Each bump, each nudge, adds another layer, and over millions of years, this dusty disk becomes a luminous whirlpool. Right at the center, pressure and heat climb to unimaginable extremes, 15 million degrees, and nuclear fusion ignites. Boom. The sun is born. For a brief, blinding moment, the newborn star screams its first light through the darkness. You can almost feel the wave of photons washing across your face. Warm, ancient, impatient. Around it, the leftover debris keeps spinning, forming the earliest planets in messy clusters of molten rock. Jupiter, Saturn, and the other gas giants begin their dance in the outer regions, sweeping up leftovers like celestial vacuum cleaners, while closer in, Mercury, Venus, Earth, and Mars are sculpted in fire. Scientists still argue whether Jupiter migrated inward first and then backed off again, a sort of solar system traffic jam that may have shaped everything we see today. It's called the Grand Tack hypothesis. Imagine Jupiter as a massive cosmic bulldozer plowing through the dusty nebula, rearranging the furniture before Earth had even unpacked its boxes. The debris that didn't form planets stays behind as asteroids, comets, and strange icy leftovers, billions of wandering fragments, each carrying whispers of the early Sunday. If you could pick one up, you'd be holding the solar system's baby photo, frozen in stone. As you drift through this glowing protoplanetary disk, you notice something hypnotic. Even the chaos has rhythm. Dust spirals inward in elegant lanes, following invisible threads of gravity. Tiny ripples of pressure carve gaps, protoplanets tugging material into orbit, carving rings like signatures in wet clay. Here's a quirky tidbit. If you compress the sun's total angular momentum and energy changes over time, the solar system technically sings. Its gravitational oscillations create vibrations, a cosmic hum that some astronomers have modeled as resonant waves. You're not imagining it, you can almost hear it, deep and slow, like the sound of eternity breathing. In this glowing cradle, time loses meaning. 1,000,000 years pass like the blink of an eye. Chunks of rock the size of mountains collide at 20 kilometers per second, fusing into embryonic worlds. Every few thousand years, something slams into something else, hard enough to vaporize both. You drift past one collision where molten rock splashes out into space, cooling into glassy beads, tiny droplets of ancient violence that billions of years later would rain down on your planet as meteorites. There's no light or dark here, only the constant shimmer of dust lit by the newborn Sunday gravity keeps pulling everything together, like a parent refusing to let go of their messy kids. And through it all, angular momentum does the babysitting, ensuring the disk flattens neatly. Because even in chaos, the universe has rules. You glide outward, feeling the pressure drop and the sun's warmth thin into the cold whisper of deep space. Here, ice crystals, drift water, ammonia, methane, all waiting to become moons, comets, or clouds on distant worlds. Some scientists think that's where your own water came from. Ancient ice balls crashing into early Earth, seeding its oceans. Others argue the opposite, that the water was always here, locked in minerals from the start. The truth? Still up for debate. But that uncertainty is part of the magic, isn't it? You're adrift in a system that's still figuring itself out, still changing, still evolving. Even today, Earth's orbit shifts, Jupiter's storms grow and fade, comets fall inward to die in a flash of vapor. The solar system isn't a static place, it's alive, breathing on cosmic timescales, always whispering new secrets. As you turn your gaze back toward the sun, you can feel the subtle pulse of light pushing against your skin, radiation pressure, the invisible wind that will one day steer solar sails across the void. That faint, steady glow once blasted away the remaining gas from this disk, clearing space for planets to emerge fully formed, like sculptures stepping out of clay. You smile softly, drifting between history and dream. You realize everything, your bones, your coffee mug, your phone screen, was once dust in this swirling cradle. The same atoms forged in that newborn sun still hum inside you, billions of years later. You are, quite literally, made of stardust. And that's not just poetic, it's chemical truth. Somewhere, a tiny spark of warmth in your chest feels like home. The solar system is vast, terrifying, breathtaking, but it's also family. You came from this, you belong here, and tonight, you're just floating back through the memories of your own making. You drift closer to the newborn sun now, where light hits your face like a furnace blast. The brightness here isn't gentle, it's aggressive, almost solid. Dust motes flash like sparks in molten air. And ahead of you, a small, battered sphere is racing around the sun faster than anything else alive. That's Mercury, the restless first planet, locked in a scorched ballet that defies reason. You feel its rhythm before you see its face. 3 spins for every 2 orbits, a bizarre resonance that makes its day longer than its year. If you lived there, and please, don't your shadow would stretch and reverse as the sun rose, paused, set, and then changed its mind to rise again. Imagine trying to plan a picnic. Mercury's surface looks like the moon's angrier cousin, gray, cratered, ancient. But unlike the moon, The temperature swings are absurd. Daytime could melt lead. Nighttime could freeze nitrogen. No atmosphere to soften the extremes. No clouds to hide from the sun's glare. Just naked stone and silence. You walk across terrain baked to 430 C, then plunge instantly into a crater so cold your breath might crystallize. Scientists still argue whether Mercury's iron core is oversized because of some primordial collision. Maybe a planet twice its size slammed into it and stripped away the lighter rock. Others think the sun's violent solar wind simply blasted its outer layers off. Either way, the result is a world that's half metal by mass. You're basically walking on the solar system's exposed skeleton. The ground beneath you quivers faintly, not from quakes, but from tidal stress. Even without an ocean, Mercury flexes under the sun's pull like a steel drum, its crust cracking with slow, silent groans. You run your fingers along a cliff that stretches hundreds of kilometers. One of the lobate scarps, wrinkles left behind as the planet shrank while cooling. It's still contracting, still folding in on itself, like a raisin in time-lapse. Here's your mainstream fact for tonight. Despite being so close to the sun, Mercury isn't the hottest planet. Venus wears that crown, wrapped in its greenhouse shroud. Mercury's lack of atmosphere means heat can't linger, it bakes, then freezes, without apology. You glance toward the horizon, and the sun looks twice as big as it does from Earth. Its light floods everything in blinding silver. And yet, oddly, the sky above Mercury isn't blue. It's black, pure and sharp, with stars visible even at noon. There's no air to scatter sunlight, no buffer between you and the raw glare of space. The shadows are sharp enough to cut. In the faint distance, you see a glimmer something, dancing on the edge of night. Mercury's exosphere. Not a real atmosphere, but a whisper-thin envelope of sodium and oxygen atoms blasted off its surface by micrometeorites and solar radiation. It's more a ghost than a gas. If you tried to breathe it, you'd die instantly. But it still counts, technically. And yet, in that fragility, there's poetry. Mercury, against all odds, still holds tiny pockets of water ice, yes, ice hidden in craters at its poles. Those craters never see sunlight, trapped in eternal shadow. Temperatures there are so low that ice brought by ancient comets never melted. So you have this surreal paradox, a planet hot enough to vaporize aluminum, also harboring frozen water at its crown. You drift over one of those polar basins. The sunlight never touches it, not directly. Instead, reflected rays bounce in faintly, lighting the crater walls in a gentle metallic glow. It's beautiful and utterly alien. You could almost imagine microbes nestled in that frozen grit, but scientists doubt life could cling here for long. Still, they can't fully rule it out. Mercury is unpredictable like that. Then there's the magnetic field. Yes, Mercury has one. Faint, but real. Even though it spins too slowly for the typical dynamo effect, it suggests the planet's core might still be partly molten. That's weird, right? After billions of years, this tiny world should have cooled solid. Something inside is keeping it warm, radioactive decay maybe, or tidal flexing, or something else entirely. Scientists still argue about it over coffee and simulation models. Here's a quirky tidbit you'll love. Mercury's orbit is a cosmic rebel. Over time, It shifts a phenomenon Einstein used to prove his theory of general relativity. The planet's elliptical path precesses faster than Newtonian physics predicted, and that tiny mismatch, just a few arc-seconds per century, was the missing puzzle piece that confirmed space-time really bends. So, in a way, Mercury itself helped rewrite the laws of gravity. Not bad for a glorified metal marble. You step onto a ridge and look back toward the Sunday. The glare washes across your vision, too bright to bear, and for a moment, you think you see waves' ripples in space itself. It's just solar wind, streaming out at hundreds of kilometers per second, bombarding Mercury's surface and throwing up plumes of charged particles. The planet has no atmosphere to protect it, no magnetosphere strong enough to shield it. The sun flays it endlessly. You remember Earth's magnetic field, that invisible guardian deflecting solar tantrums. Mercury has no such comfort. It just takes the hit every day, silently, yet somehow it endures. That resilience feels strangely human. If you could stand here long enough, say, a few million years, you'd watch the craters fade under constant micrometeorite bombardment. Mercury's face is rewritten slowly, grain by grain, dust turned to glass by sunlight. Its entire surface glows faintly in ultraviolet light, a shimmering gray that looks almost alive. As you drift upward, the world shrinks beneath you, swallowed by the sun's radiance. From this height, you see its orbit traced like a faint thread of silver around the star. So close, so fast, so fragile. Mercury isn't just the first planet. It's a survivor, a scarred veteran of cosmic violence still circling the flame. You smile at the thought. It's easy to overlook the small, scorched things, the ones closest to danger. But sometimes, they're the most enduring. Mercury keeps spinning, locked in its strange rhythm, whispering secrets of the sun's fury and time's patience. You drift away, feeling the temperature fade, your skin cooling as darkness swallows you. Behind you, the little world glints, half ice, half iron, half madness, and somehow perfectly balanced. You glide outward now, away from Mercury's blistering brilliance, into a pale golden light that thickens into haze. The sunlight dims slightly, but the air, or what looks like air, glows like melted brass. Before you even see the planet, you feel it. A heavy, endless pressure, like standing inside a furnace wrapped in velvet. You've arrived at Venus, the hellish twin. From a distance, she's a deceiving beauty. A perfect marble of soft yellow clouds, smooth and featureless, gleaming like polished ivory. But step closer, and the illusion cracks. Beneath that creamy veil lies a world so violent it could crush a submarine. The atmosphere is carbon dioxide so dense that it behaves like liquid at the surface. The pressure? 90 times that of Earth. You'd feel it instantly, bones cracking, lungs flattening, your body reduced to abstract art in seconds. But tonight, you're immune to harm. You drift through the cloud deck like a ghost, feeling static crackle around you. Lightning flashes silently in the distant tendrils of white fire leaping across sulfuric acid clouds. The smell, if you could smell it, would sting like burning match heads and vinegar. Venus rotates backwards, an oddball among planets. On most worlds, the sun rises in the east. Here, it rises in the west, and so slowly, that a Venusian day lasts longer than its year. Scientists still argue how that happened. Maybe a colossal impact flipped it, or gravitational tugs from Earth and the Sun twisted its spin over eons. Either way, Venus decided to dance to her own rhythm. Here's your mainstream fact. Venus is the hottest planet in the solar system, hotter than Mercury, despite being farther from the Sunday. The culprit? A runaway greenhouse effect. The thick atmosphere traps heat so efficiently that surface temperatures stay around 475 C, day and night, everywhere. No seasons, no relief, just eternal simmering. And yet, Venus once might have been gentle. Models suggest it could have had shallow oceans billions of years ago. Imagine soft waves rippling under an orange sky, rain falling through carbon haze. But something tipped the balance. Maybe a volcanic surge, maybe slow evaporation. The oceans boiled, carbon dioxide flooded the air, and the planet spiraled into a greenhouse inferno. Scientists still argue whether that transformation happened suddenly or dragged out over millions of years, a planetary version of slow heartbreak. You descend through the clouds, drifting past layers tinted gold, then ochre, then deep rust. At about 50 kilometers up, the temperature feels almost comfortable, a balmy 25 C. It's strange to think that in this layer, above the crushing surface, the air pressure is close to Earth's. Some scientists dream of floating cities here, balloon habitats drifting in the upper Venusian sky, where humans could live in perpetual twilight. It's one of those maybe someday ideas that feels halfway between genius and delusion. But the deeper you sink, the darker it gets. Sulfuric mist thickens, light scatters into a perpetual amber glow, and gravity presses you down into a place where the sky touches the ground. The landscape that emerges is haunting. Endless plains of cracked basalt, mountains named after goddesses, and vast shield volcanoes slumbering beneath the haze. You drift over Mart Mons, a giant volcano the size of Mount Everest. Radar mapping from orbit shows signs that it may still be active. If that's true, Venus isn't as dead as it looks. It's still exhaling, still reshaping itself beneath the smothering heat. Some believe the planet undergoes global resurfacing events, where its crust melts and reforms every few 100 million years. Imagine the entire planet turning itself inside out in slow motion. And here's your quirky tidbit. Venus has snow. Not the water kind, of course, but metallic frost bismuth sulfide and tellurium-coating mountain peaks. They shimmer faintly in the dim light like powdered gold. So, yes, Venus has snow-capped mountains made of metal. It's almost poetic. If you ignore the 900 flesh air and acid rain, the surface wind barely moves, crawling slower than a walking pace. Yet the atmosphere above roars. The upper clouds race around the planet at 360 kilometers per hour, completing a full circuit every 4 Earth days, a phenomenon called superrotation. Scientists still don't fully understand what powers it. How can air so thick move so fast when the planet itself turns so lazily? It's as if Venus wants to hide its stillness beneath the illusion of speed. You brush past a valley carved by lava rivers long cooled into stone waves. The ground glows faintly with residual heat. Even though no sunlight reaches here, the sky is never truly dark. It's a dim, perpetual twilight where shadows fade instead of forming. The horizon ripples like liquid through the dense atmosphere, And then you feel it, a faint, rhythmic vibration beneath your feet. Quakes. The planet shifts, grumbles, releases tension, like a sleeper turning in bed. Venus may not have plate tectonics like Earth, but it still moves. Its crust is thin, brittle, restless. You remember that both Earth and Venus started with nearly the same ingredients. Two worlds born side by side, same size, same materials, same early warmth. Yet one became paradise, the other purgatory. Some scientists wonder if Earth could meet the same fate. If our atmosphere thickened, our oceans boiled, our sky turned orange, would we end up like this? The thought lingers uncomfortably, like a whisper from the future. As you rise back into the golden haze, the pressure eases and the landscape melts into a honey-colored blur. The sunlight above splits into rainbows as it filters through acid droplets. It's oddly beautiful, this deadly, radiant world. You float upward past the lightning again. Each flash is silent, but the glow pulses like a heartbeat. For a moment, the clouds almost look alive. You think about how little we truly know. Every probe we've sent here has died, quickly melted, crushed, or shorted out within hours. Venus keeps her secrets well. Maybe, one day, we'll build something strong enough to last, to listen, to whisper back. Until then, she spins quietly beneath her toxic veil, a warning and a wonder both. You rise above the clouds and look back down. The planet glows softly, like candlelight under a silk sheet. It's so beautiful from afar, you'd never suspect the inferno beneath. Beauty and danger, twined like lovers. Venus wears both perfectly. The sun glints off her edge, and for a moment, you can almost believe she smiles back. Then she fades into the brightness behind you, and the black ocean of space swallows her whole. You drift outward again, leaving Venus' golden furnace behind, and suddenly, the darkness feels clean cold, like rinsed glass. The next world appears ahead of you, spinning gently in the light like a calm blue marble wrapped in thin white silk. Earth, home. You've seen it 1,000 times in pictures, but from here, hanging in the dark, it's still almost impossible to believe it's real. The oceans glint first, that impossible shade of blue, the color of calm, of gravity holding everything in place. Then you see the swirl of clouds curling above continents, the snowcaps, the deserts, the green bruises of forests and fields. You feel it in your bones. This place shouldn't exist. It's too balanced, too lucky, too absurdly alive. You hover at the edge of its atmosphere, where thin ribbons of aurora pulse in curtains of emerald and violet. The magnetosphere hums faintly, an invisible force field sculpted by the planet's molten heart. That's your first mainstream fact tonight. Earth's magnetic field deflects the solar wind, the same radiation that strips air from planets like Mars, and without it, the atmosphere would slowly vanish. You'd be left with nothing but dust and regret. Below, lightning flashes over the Pacific, and you realize each strike releases energy hotter than the surface of the Sunday. It's chaotic, but it's also order wrapped in chaos. A perfect cycle that's been running for 4 billion years. You descend through the atmosphere, feeling the air thicken, warm, and sing with life. Every molecule here is a story. The oxygen you breathe comes from ancient cyanobacteria, that once turned Earth's sky from suffocating red to breathable blue. The nitrogen, that's stardust too, forged in the bellies of long-dead suns. Even the carbon in your breath traces back to supernovae that exploded before the solar system was born. You land softly on the edge of a vast ocean at twilight. The water sighs against black sand. The smell salt, ozone, a whisper of life wraps around you like memory. Somewhere, a whale sings, its voice echoing through water thicker than air, reaching across entire oceans. That low song, oddly enough, sounds a lot like the electromagnetic hum of Jupiter's magnetosphere. Coincidence? Probably. But it makes you smile anyway. You run your fingers through the sand. And here's a little quirky tidbit. Every grain of it, the one slipping between your fingers right now, is older than every city, every building, every person alive. Some are fragments of ancient volcanoes, others pulverized coral skeletons. You're literally holding recycled history, polished by time and tide. Earth spins under you, steady but not still. Its axial tilt 23.5 degrees gives you seasons. Without that tilt, there'd be no winter, no spring, no reason for life to migrate or evolve. Scientists still argue whether the moon's gravitational pull stabilized that tilt or simply kept it from tumbling chaotically. Either way, your companion in the night sky is part of why you're here at all. And about that moon, remember it. We'll be visiting soon. For now, it hangs above you like a quiet overseer, tugging at the tides, keeping Earth's rhythm steady. If you could step back in time, you'd see a very different planet. 4 billion years ago, this same blue sphere was molten, constantly bombarded by asteroids. Steam hissed from endless volcanic vents, forming the first atmosphere. Water condensed, rained for millions of years, and pooled into the basins that became oceans. Somewhere in those warm shallows, chemistry blinked and decided to start dreaming. Scientists still argue over how it happened. Did lightning spark the first amino acids into existence? Did comets deliver the right cocktail of carbon and water? Or did life come from vents in the deep ocean, where superheated water mixed with minerals in perfect balance? No one knows. But one day, something copied itself, and that was enough to change everything. The air tonight feels gentle, alive with stories. You can hear wind moving through trees, crickets calling, waves folding themselves over and over on the shore. It's easy to forget that this entire system, the magnetosphere, the ozone layer, the atmosphere, is a knife-edge balancing act. Change any one factor too much, and it all collapses. You wander inland. The ground hums faintly, tectonic plates grinding beneath your feet. The slow-motion heartbeat of the planet. Volcanoes recycle minerals into the air. Oceans capture carbon. Forests breathe oxygen. Everything is connected in loops so intricate that even the most brilliant computers struggle to simulate them fully. Earth runs on self-correction, a built-in resilience that's almost sentient. Yet, she's not immune to chaos. Every few 100 million years, something happens. A meteor strike, a magnetic reversal, a mass extinction, and Earth resets. Life retreats, then blooms again. You're walking on a survivor, a planet that's reinvented itself 5 times and still keeps the lights on. You climb a ridge and look out over the curvature of the world. It's subtle, but you can see it, the horizon bending away, proof that you're standing on something vast. Above, the stars are sharp pinpricks. You spot Venus glowing near the twilight edge, the ghost of Mercury hiding below it, and beyond them, the sun, your constant, searing heart. Everything you've seen so far is still up there, still dancing in their predictable chaos. Here's something funny. The sun and moon appear almost the same size from Earth's surface. That perfect coincidence is what gives you solar eclipses the celestial just right alignment that makes your sky so dramatic. Out of all the millions of planets out there, that visual trick might be unique to this one. The odds are absurdly small. You live under a cosmic coincidence. The night deepens, and the Milky Way drapes itself overhead, a silver river spilling through darkness. Somewhere in that galaxy are trillions of other planets, and yet, for now, this one remains the only confirmed harbor of life, a pale dot that learned to ask questions. You take a slow breath and feel something soft unfurl in your chest, a kind of gratitude mixed with awe. Every atom of you once belonged to this cycle. Every breath you take was exhaled by something living long before you. You're not a visitor here. You're part of the machinery. The wind cools, and the ocean hums. The planet keeps spinning, steady as ever, balancing light and dark, chaos and calm. Earth, the improbable, the fragile, the masterpiece spins beneath your drifting gaze, the perfect interlude between inferno and ice. The blue fades behind you as you drift higher, past the clouds, past the soft cocoon of air, until Earth becomes a delicate globe, below glowing faintly against the void. But beside it hangs another world, smaller, paler, quieter, the moon. You move toward it effortlessly, feeling gravity's tug fade from Earth and shift toward this grey companion. Up close, the moon isn't smooth like you imagine from Earth's nights. It's jagged, scarred, older than any mountain, and covered in fine dust, so soft it clings to everything, but so sharp it could slice through your gloves. You land in silence, absolute silence. No wind, no sound, no breath. The ground is powder, crushed rock older than the first tree on Earth. You glance at the horizon, and it's strange, shallow, curving sharply because the moon is so small. The sky isn't sky at all, just black infinity hanging directly above a blazing Sunday. Shadows here are bottomless, and light is pure, unfiltered white. Here's your mainstream fact for tonight. The moon is drifting away from Earth, about 3.8 centimeters every year. It doesn't sound like much, but give it enough time, and one day, total solar eclipses will be a thing of the past. Earth and moon are dancing apart, slowly, inevitably, like two partners who know the rhythm can't last forever. You walk toward a crater's edge, Tycho, sharp and fresh by lunar standards. You can see rays of ejecta fanning out for hundreds of kilometers, frozen traces of a colossal impact that happened 100 million years ago. It's eerie, standing here, knowing this place hasn't changed since dinosaurs saw it from Earth. Scientists still argue exactly how the moon formed. The leading theory is that a Mars-sized body, Theia, slammed into early Earth. The impact was catastrophic, vaporizing rock and flinging molten debris into orbit. That debris, caught by gravity, fused into the moon you see now. But some evidence suggests the two bodies might have merged more gently, forming what researchers poetically call a synestia, a donut-shaped cloud of molten rock and vapor that cooled into Earth and Moon together. Either way, the result was this: a companion born from collision, orbiting ever since. You kick the dust and watch it rise, then fall in slow, hypnotic arcs. With no air resistance, it moves like liquid silk, drifting lazily before settling again. Astronauts once said, lunar dust smelled faintly like gunpowder, an odd reminder that even alien ground can trigger something familiar. A quirky tidbit for you: the moon has quakes, moonquakes. Some are caused by meteor strikes, others by the gravitational pull of Earth squeezing its crust. During certain times in its orbit, the moon literally groans. The Apollo seismometers picked them up soft, ghostly tremors that sometimes lasted 10 minutes or more. So even this silent world isn't entirely still. It breathes. Slowly, in stone, you wander toward the horizon, where the sunlight fades and shadow begins. In this twilight zone, the temperature drops hundreds of degrees in a few steps. At night, it's colder than Antarctica's darkest winter. At day, it's hotter than boiling water. The moon doesn't do moderation, but it does reflection. You look up, and there it is, Earth, hanging in the black sky, glowing blue and white, huge and bright. From here, it never rises or sets. It just hovers, slowly rotating, showing you Africa, then the Pacific, then the silver swirls of cloud. It's breathtaking. If you whisper, you imagine maybe someone down there could hear it in their dreams. You notice how the surface beneath you shimmers faintly with sunlight, reflecting off dust. The fine particles are electrostatically charged by solar radiation. And at the boundary between night and day, the lunar terminator, they can even lift into the air, forming a thin, ghostly mist of floating dust. Scientists still argue about this lunar horizon glow. It's one of those small, unsolved mysteries that make the moon feel almost alive, as if it's exhaling light. And here's a thought that never fails to blow your sleepy mind. Without the moon, Earth's rotation would be chaotic. The tides it raises don't just move oceans. They stabilize the planet's tilt, keeping climates predictable enough for life to evolve. Without that tidal anchor, Earth might wobble like a spinning top, its poles wandering wildly. So when you look up at the moon, remember it's been Earth's therapist for 4 billion years, keeping her balanced while she spins through chaos. You kneel, brushing your hand over a smooth piece of basalt. It's cold, lifeless, but once it was lava flowing across this barren surface. The moon was geologically active long ago. Volcanoes built plains, now called Maria Latin for seas. Early astronomers thought they were oceans. You can see why. From Earth, those dark blotches look like calm lakes, almost inviting, but they're frozen floods of ancient fire. As you drift along, you see one of the old Apollo landing sites, just a few metallic shapes half buried in dust. The flag still stands, though it's probably bleached pure white by ultraviolet light. The footprints are still there too. They'll remain for millions of years, untouched by wind or rain. Humanity's quiet graffiti on eternity. If you pause long enough, you feel it. The faint rhythm of orbits, Earth and Moon locked in a gravitational waltz, the same face always turned toward home. The far side, often called dark, isn't really dark at all. It just faces away, unseen, mysterious. That's where you head now, gliding silently over the rim. The terrain there is rougher, older, riddled with craters that never see Earth's glow. The stars look sharper from here. Time feels slower. You could almost fall asleep standing. The only light comes from the sun's edge, a silver knife cutting through black. You remember something from earlier, the grand tack, Jupiter's chaotic migration, the near-miss collisions that sculpted this system. The Moon's story is part of that chain, a scar left by ancient violence that accidentally gave rise to stability. Every breath you've ever taken, every tide that's ever pulled back from a beach, owes itself to this grey sphere hanging in eternal silence. You rise again, leaving the crater fields behind. The Moon shrinks below you, turning once more into a pale coin against the velvet dark. Earth shines beside it, radiant and alive, the two bound together in invisible thread. You smile softly. The universe is cruel sometimes, but tonight it feels oddly tender. You drift onward, pulled gently by sunlight and momentum, leaving the Moon behind like a memory fading into sleep. Ahead glows a brilliant beacon, Mercury, the smallest, swiftest, and most sun-scorched planet in your neighborhood. You approach carefully, because there's no atmosphere here to cushion your arrival. Only rock, heat, and radiation. From a distance, Mercury looks like a miniature moon, grey, cratered, ancient. But as you get closer, you see differences. Its surface gleams with metallic streaks, and the shadows look even deeper, as if light itself struggles to survive here. The sun looms enormous in the sky, 3 times larger than from Earth, and the light is so fierce it seems almost solid, pressing against your skin like a weight. Here's your first solid fact to tuck under your pillow. Mercury is shrinking. That's right. The planet is literally contracting as it cools. Its metallic core is slowly solidifying, causing the crust to wrinkle and form massive, cliff-like features called lobate scarps. Some of them stretch for hundreds of kilometers and rise higher than the Himalayas. Imagine an entire planet aging, its skin folding as it loses internal warmth. A cosmic wrinkle, billions of years in the making. You take a step, or what feels like one. The ground beneath you is baked rock, but there are places cold enough to freeze metal solid. Despite being closest to the sun, Mercury hides patches of permanent ice in the shadows of its polar craters. The tilt of its axis is so slight that sunlight never reaches those deep depressions. It's the universe's idea of irony, a planet hot enough to melt lead, hoarding glaciers in eternal night. You peer into one of those dark polar craters. Inside, it looks like obsidian dust, silent and untouched. Radar from Earth confirmed those bright signatures decades ago, evidence of frozen water trapped for possibly billions of years. You can almost hear scientists arguing across time. Does that mean Mercury could have delivered some of Earth's water after all? The debate still flickers like static in the background of astronomy conferences. There's a faint shimmer near the horizon-o atmosphere, remember. But there's something else, a whisper-thin exosphere, made mostly of sodium, potassium, and traces of oxygen. It's not enough to breathe, not even enough to feel, but it's there, like a ghost of what might have been if Mercury were larger. Solar radiation constantly strips atoms from its surface, sending them drifting into space like dust from a burned-out world. Quirky tidbit time. Mercury's day is longer than its year. It spins so slowly that while it orbits the Sun every 88 Earth days, it takes about 176 days for the Sun to rise, set, and return to the same spot in the sky. That means, if you lived here, which, let's be honest, you wouldn't survive, you'd see dawn stretching endlessly into day, then a sunset that lasts weeks. The sky wouldn't change much, but the ground temperature would swing from freezing cold to oven hot with cruel indifference. You stand perfectly still and watch the horizon glow faintly blue. It's caused by sunlight scattering off dust and charged particles sputtering from the surface. Messenger, the spacecraft that once orbited here, saw this eerie blue haze, beautiful, delicate, and utterly deadly. Mercury's orbit is another oddity. It's not a perfect circle but a stretched oval, more eccentric than any other major planets. That means the Sun's size and brightness change dramatically during each orbit. You might imagine how bizarre that feels, standing here, watching the Sun swell and shrink, the light pulsing like a heartbeat. And here's where Einstein steps in. Mercury's orbit helped confirm general relativity. Scientists noticed its path didn't quite match Newton's predictions. The point where it comes closest to the Sun, called perihelion, shifts slightly each orbit. Newton couldn't explain it, but Einstein could. The Sun's gravity, curving space itself, was bending Mercury's path in a way classical physics couldn't handle. So every time this little world loops around, it's proof that space-time really does ripple and twist just as the equations say. Scientists still argue over what Mercury's core is truly like. It's huge, taking up about 85% of the planet's radius and mostly metallic iron. Some theories suggest a massive collision stripped away Mercury's outer layers, leaving just its dense heart. Others propose it formed that way from the start, in a hotter inner disk of the early solar system, where lighter materials never condensed. Either way, you're standing on the cosmic equivalent of a bare engine block, a planet reduced to essence. You find one more strange beauty before you leave. Mercury has these spider-like patterns called hollows, bright, shallow depressions with no impact origin. They might form when volatile elements like sulfur or potassium vaporize under solar heat, leaving tiny pits that glint like frost. They're brand new by geological standards, maybe still forming. Imagine that. Even here, the most battered world still finds ways to change, to move, to breathe. In its own scorched silence, you crouch, press your gloved hand into the dust, and feel nothing, because there's no air to carry heat, no molecules to transfer warmth. The silence here isn't peaceful, it's absolute. You could scream into the horizon, and not even an echo would remember you. You tilt your head back, watching the sun blaze so bright it's nearly white. Mercury doesn't just orbit the sun, it races it. This little world moves at nearly 47 kilometers per second, the fastest in the solar system. You can almost sense the centrifugal pull as the surface hums underfoot, the faint tremor of orbital speed, wrapped in stillness. For a fleeting moment, You feel sympathy for this world scorched, scarred, and lonely. No moons, no clouds, no atmosphere to shield it, just eternal sunlight and shadow. And yet, it keeps going, circling endlessly, carving its path around the sun like a patient stone in a celestial clock. Before you drift away, you glance back once more. The cliffs stretch for hundreds of miles, ancient fractures curling around the horizon. The sun throws long, liquid shadows across them, painting a world both frozen and aflame. You could almost swear the light flickers softly like a heartbeat, faint but steady. You turn your gaze outward, toward the golden glint, waiting deeper in space. Venus, beautiful, blinding, and boiling. You're about to meet the planet that wears clouds like silk but hides a hell beneath. You let the light pull you in. You can feel the temperature of light change before you even see Venus clearly. The harsh white glare of the sun begins to glow gold, thickened by an invisible haze. You slow your drift as the planet grows beneath you. A smooth, creamy yellow sphere wrapped entirely in cloud, as if sculpted from ivory and fog. It looks gentle, peaceful even, but you already know that calm is a lie. Venus is the solar system's greatest catfish. Beneath that soft, pearly veil lies the most brutal surface you could imagine. You sink slowly through its clouds, watching them swirl in elegant bands. But the deeper you go, the thicker and darker they become. It's like descending through a sea of smoke, and soon the light starts to turn amber, then orange, then bloody red. Lightning flashes silently inside the mist-huge, branching bolts that stretch for kilometers at a time. Your suit sensors scream as the heat rises 200 degrees, 300, 400. The pressure climbs too, crushingly. By the time you reach the surface, it's the equivalent of standing a kilometer underwater. You can't see the sun anymore, only an orange glow pressing through sulfuric haze. The air is thick enough to feel, and it's made mostly of carbon dioxide, with a touch of sulfuric acid for spice. Every breath would burn your lungs. Every exposed inch of skin would dissolve. Here's your mainstream fact to hold on to. Venus is hotter than Mercury, even though it's farther from the Sunday. Its dense atmosphere traps heat in a runaway greenhouse effect, so intense that the surface temperature never dips below about 465. Hot enough to melt lead, zinc, or your favorite spacecraft. It's what happens when a planet's climate system goes completely rogue. You wander, or rather, float carefully through this hellscape. The ground is a patchwork of shattered basalt plains and volcanic domes. Some are the size of small countries. Venus is a volcanic world through and through. Its entire surface was resurfaced by lava roughly 500 million years ago. The crust seems frozen mid-flow, like spilled caramel hardened under pressure. And yet, scientists still argue whether Venus might still be active. In 2023, radar data hinted at a volcano that seemed to change shape, possibly erupting. If true, that would make Venus one of the few places besides Earth with ongoing volcanism. Imagine that. Somewhere under these burning skies, lava might still bubble up, endlessly rewriting the planet's face. A quirky tidbit for your sleepy mind. A day on Venus is longer than its year, and it spins backward. It takes 243 Earth days to complete one rotation, but only 225 days to circle the Sunday. The sun rises in the west and sets in the east, but so slowly that if you stood here long enough, say, for months, you'd see it crawl across the horizon, freeze, and then slide back the other way. It's a planet with no hurry and no mercy. Your visor fogs slightly, and you tap the glass just to see the landscape clearer. Rocks everywhere, flat, fractured, some with weird, smooth edges, as if melted and reformed again and again. The ground ripples slightly with mirages. Even at these temperatures, light bends like liquid. You half expect to see water, but there's none left here, only memory. Once, long ago, Venus may have been Earth's twin in more than size and mass. Models suggest it might have had oceans, rain, maybe even calm blue skies. But as the sun brightened and greenhouse gases accumulated, the water evaporated. With no oceans to absorb carbon dioxide, the planet spiraled into thermal madness. Some scientists still argue about whether Venus's oceans lasted millions or hundreds of millions of years, and whether life could have flickered briefly before everything boiled away. Lightning crackles again, illuminating the sky in ghostly white veins. You imagine the atmosphere above, where the clouds are thinner, cooler, and maybe, just maybe, habitable. That's the fringe idea that refuses to die. That microbial life might survive in the upper atmosphere, floating in droplets of sulfuric acid, feeding on sunlight and chemistry. A floating biosphere, 30 miles up, far above the inferno below. NASA's even floated the idea of sending airships, their balloon-like labs drifting forever in Venus' golden haze. You smile at the absurdity of it. Cloud cities on a planet where the ground itself tries to murder you. You step onto a rise, a low volcanic dome, and look across the landscape. Everything is bathed in dim amber light. Mountains in the distance ripple like mirages, and the air seems to shimmer with heat so thick you can almost touch it. The horizon curves close. Venus's sky is heavy, bending vision itself. Your instruments pick up a faint hum, radio static perhaps. The Soviet Venera landers once transmitted from here, briefly. Venera 13 lasted 127 minutes before the heat and pressure crushed it into silence. You can almost hear its last signal echo faintly, a dying heartbeat in the static. The probe's color photos were the first and only close-up views humans have ever had of this world. They showed rocks like golden pancakes and a sky that looked bruised, like an old photograph aging in real time. You imagined setting up camp here, though you wouldn't last a second without shielding. The sound of acid rain hissing against the surface fills your ears. It evaporates before it even touches the ground. The irony isn't lost on you. A world drowning in greenhouse gas, yet thirsting for rain. A faint tremor shakes the ground beneath your boots. Probably just heat convection, though some scientists suspect Venus might have Venusquakes, small seismic rumbles from a restless mantle. This planet isn't dead. It's just simmering beneath its own suffocating blanket. Above you, the clouds swirl with hypnotic speed. Despite the planet's slow rotation, the upper atmosphere races around at over 300 kilometers per hour, completing a full circuit every 4 Earth days. That phenomenon, superrotation, still puzzles scientists. Why should the atmosphere move 60 times faster than the ground below? Some think it's the uneven heating between day and night. Others blame turbulent feedback loops, but no one knows for sure. You glance upward, through the thick haze, trying to see stars. There are none. The sun is a dim, round wound behind the sulfur glow. Venus doesn't do stars. It keeps its secrets close. You can't even see the horizon clearly anymore. Just a constant haze of motion and heat. It's time to leave. As you ascend through the atmosphere, the pressure drops, and the clouds shift color again from amber to cream to dazzling white. The lightning fades, replaced by calm sunlight scattering off endless cloud tops. Up here, the temperature feels almost Earth-like, the air almost kind. You hover at this perfect altitude where human airships could one day drift. Maybe this is what redemption feels like, a fragile layer of safety above the chaos. You glance back one last time. The surface below glows faintly orange, like the inside of a furnace. And for a strange, fleeting moment, it looks beautiful hell, wearing a halo. The golden light pulls you onward now, away from the suffocating heat, toward the bright blue speck waiting further out. Earth is calling. You rise through Venus's golden fog, the heat finally peeling away from your skin, until the air thins into nothing and the silence takes over again. The clouds fade into a pale shimmer, and before you, Earth hangs like a sapphire lantern against the dark. It looks fragile, haloed in white swirls and blue oceans, and for the first time in this cosmic drift, you feel something close to home tug gently at you. You drift closer, the colors deepening blues turning into oceans, greens into continents, white into clouds moving like slow breath. The planet spins below you, alive in every sense, a glowing marble of storms and sunlight. You catch sight of the Terminator line, where day gives way to night, and its breathtaking city, lights flickering like neurons in a living brain. You've arrived at the only world known, so far, to host everything from poets to tardigrades. Here's your mainstream fact for this section. Earth isn't a perfect sphere. It's slightly squashed at the poles and bulging at the equator, an oblate spheroid. You owe that to the planet's rotation. It spins fast enough to stretch its own waistline by about 21 kilometers, which means technically, people at the equator are farther from Earth's center than anyone at the poles. So if you ever feel a little off balance, blame centrifugal force. As you descend, clouds peel apart, revealing the vast Pacific Ocean a mirror of blue, reflecting the sun like liquid glass. Down there, waves rise and fall under the pull of a distant friend, the moon. You remember its slow retreat, the dance you saw earlier. The same rhythm moves these tides, sloshing gently across the curve of the world. You hover over a continent, maybe Asia, maybe Africa. It's hard to tell from up here. The lights of cities bloom softly through the clouds, humanity's fireflies. The air hums with invisible energy radio waves, Wi-Fi signals, satellite transmissions, forming a halo of chatter around the planet. Earth isn't just alive biologically, it's alive electromagnetically, constantly whispering to itself in static and code. You slip lower, through the upper atmosphere. Wisps of oxygen and nitrogen brush against you, faint blue ribbons glowing at the edge of dawn. The air smells like ozone and rain before a storm. A soundless wind rushes past your ears, the first true atmosphere you've felt since leaving home. And now for the quirky tidbit. Earth's atmosphere actually extends far beyond what anyone expects. The outermost layer, called the geocorona, stretches almost to the Moon's orbit. It's made of sparse hydrogen atoms, faint enough to be invisible, but technically part of the planet's exosphere. So when Apollo astronauts left Earth, they were still inside its outer atmosphere, without realizing it. You've been living inside an invisible bubble all along. You glide across the curve of the world, watching storms swirl below massive cyclones with eyes as calm as meditation. You could fit entire countries inside some of those spirals. Lightning flashes deep in their bellies, the same kind of cosmic energy that may have sparked life's first molecules billions of years ago. Scientists still argue how life actually began here. Was it born in deep-sea hydrothermal vents, cradled by volcanic heat and minerals? Or did it arrive from elsewhere, seeded by icy comets carrying amino acids through the void? The debate drifts endlessly like plankton, each theory glowing faintly, never fully extinguished. But somehow, chemistry turned into biology, and the planet learned to breathe. You touch down lightly on the edge of a mountain range. Let's call it the Andes, though the name doesn't really matter. The air is crisp, filled with the soft scent of stone and wind. You look up, and the sky feels impossibly wide. It's the same sky that holds everything: weather, sunlight, satellites, dreams. If you listen closely, you can almost hear the planet's heartbeat, the low, slow hum of earthquakes rolling deep beneath the crust. Earth's surface is restless, shifting and cracking under the push of plate tectonics. Those plates float on molten rock like rafts on a sea of fire. Every mountain you see, every trench in the ocean floor, is a ripple of that ancient, ceaseless motion. It's easy to forget how violent Earth once was. In its early days, it glowed red with magma oceans. Comets bombarded it constantly, delivering water and chaos. Yet somehow, through the violence, stability emerged. The magnetic field formed, shielding life from radiation. The atmosphere thickened. Oceans gathered. Then came cyanobacteria, the original terraformers filling the air with oxygen and paving the way for everything else. You tilt your gaze toward the aurora, the northern lights, flickering at the pole like curtains of green fire. They shimmer and dance, because charged particles from the sun are colliding with Earth's magnetic field. It's a living light show, powered by cosmic weather. Those same solar winds strip atmospheres from lesser worlds, but Earth fights back, wrapping itself in a magnetic cocoon. Without it, we'd be as dry and dead as Mars. Speaking of Mars, he's waiting out there, glowing red on the edge of night. You'll visit him soon enough. But for now, stay here a moment longer. You've earned it. Down below, you see deserts, forests, rivers, glaciers. You could spend a lifetime exploring and still not touch every mystery this planet holds. And yet, humans dream constantly of leaving it. Maybe that's the paradox of intelligence. To crave the stars, even while standing on paradise. You hover above a thunderstorm, watching lightning carve through clouds in slow motion. Each bolt reaches for the ground, illuminating forests and seas like a heartbeat. The energy in one thunderstorm could power entire cities, if only it could be tamed. But maybe it's better this way. Nature needs a little untamed magic to stay beautiful. You drift higher again, through the thinning air. The blue fades to black, and Earth's curve sharpens into a perfect arc. The sun peaks over the horizon, and for a split second, you see the atmosphere as a thin, glowing halo, just a few dozen kilometers thick, yet the only barrier between life and vacuum. From this height, the entire biosphere looks like a shimmering film of breath. Every tree, every ocean wave, every lung on the planet, exhaling together. You realize that everything you've seen so far, the craters of Mercury, the inferno of Venus, the frozen moon, exists in a cosmic desert compared to this one lush oasis. Earth isn't just another rock orbiting a star. It's the universe's most elaborate chemistry experiment. And somehow, it worked. You turn one last time, taking in the sight. The auroras still dance. The oceans still glitter. The continents still drift, slowly rearranging the face of the world. You can almost feel the planet rotating beneath you, a silent spin that turns day into night, life into memory, and memory into myth. It's time to move on, though. The red world is calling Mars, the desert planet, the dream of explorers, the mirror of humanity's curiosity. You let the pull of the sun carry you onward, leaving Earth glowing softly behind like a nightlight in the dark. The blue fades behind you again, and the light shifts from ocean to ember. Ahead lies a world so familiar it hurts to look at it. A planet that feels like Earth's shadow in red. Mars rises slowly from the darkness, small but proud, its rusty skin glowing faintly under the sun's distant light. You feel the pull of nostalgia for a place you've never been, like seeing an old photograph of a home you might have had in another life. You approach the planet's thin halo. It's a faint whisper of atmosphere, tinted pale orange. You can see dust floating even from space, swirling in vast, slow-motion storms. As you descend, the details sharpen. Canyons deep enough to swallow Mount Everest whole, volcanoes that dwarf anything on Earth, and plains carved by long-gone rivers. Here's your mainstream fact for tonight. Mars once had liquid water rivers, lakes, maybe even a shallow ocean in the north. Evidence lies everywhere. Dry riverbeds snaking through the desert, minerals that only form in water, and ancient shorelines visible from orbit. Billions of years ago, Mars may have had blue skies, rain, and even a magnetic field to protect it. Then, something changed. The planet's core cooled, the magnetic shield faded, and the solar wind stripped away its atmosphere grain by grain. The oceans boiled into space, leaving only frost and memory. You land softly on a plain, the color of cinnamon, dust rising like smoke in the low gravity. The air is thinless than 1% of Earth's pressure, and full of carbon dioxide. The wind hisses faintly, carrying grains of iron oxide that stain everything red. You crouch down and scoop some of the soil through your gloved fingers. It clings stubbornly, magnetic and dry, as if refusing to let go of its secrets. Off in the distance, a mountain looms Olympus Mons. You start toward it, knowing it's not just a mountain, but the largest volcano in the solar system, nearly 3 times the height of Everest, and wide enough to cover France. Its slopes are so gentle you could walk from base to summit and barely notice the incline. You look up at its edge and realize it's too big to see the top from here. The curve of the planet hides it from view. Quirky tidbit time. Mars has blue sunsets. It's the opposite of Earth. Where our skies are blue and sunsets red, Mars scatters light differently because of its fine dust. So as the sun sets, The sky around it glows a haunting blue halo, while the rest of the heavens stay reddish-brown. Imagine standing here, watching a pale blue dusk settle over a rust-colored desert, a lonely inversion of home. You climb higher, and the air grows even thinner. The sun looks smaller now, just a white coin in the hazy salmon sky. You pause to catch your breath. Not that it matters. Your oxygen comes from a tank. But something about the silence makes you slow down. The horizon stretches forever, flat and endless. If loneliness had a color, it would be this. Scientists still argue about whether life ever existed here. The Viking landers in the 1970 seconds detected strange chemical reactions in the soil, some resembling metabolism, others just chemistry. Later missions, like Curiosity and Perseverance, found organic molecules and methane plumes that appear and vanish mysteriously. Some researchers swear it's biology. Others say it's just sunlight breaking down rocks. No one knows for sure. Mars keeps its secrets buried. You find a rock shaped like a fossil, almost teasingly organic. It's probably just erosion, but for a moment, you can't help but imagine. Maybe microbes once drifted in these ancient rivers. Maybe they froze when the world turned cold, waiting for warmth to return. Or maybe life here never got the chance at all. Either way, Mars is a story of what almost was. The wind picks up, and the horizon blurs. A dust storm begins to form soft at first, like a whisper, then heavier. The sky turns copper, and fine grains sting your visor. Mars's storms can grow to engulf the entire planet, wrapping it in a red veil for months. In 2018, one such storm ended the mission of NASA's Opportunity rover after 15 years of loyal service. It went to sleep under that darkened sky. Its final message, a simple, haunting line. My battery is low, and it's getting dark. You can't help but feel that echo now. The dust clears slowly, revealing the deep scar of Valles Marineris. You hover over it, and your mind goes quiet. This canyon system is 4,000 kilometers long, 200 kilometers wide, and up to 7 kilometers deep, stretching across a fifth of the planet's circumference. It's as if Mars tried to split itself open and froze mid-scream. Scientists still argue how it formed. A collapsed crust, a series of ancient faults, or maybe erosion from vanished rivers. Whatever the cause, it's a wound so immense it defies comprehension. You descend into the shadows of its cliffs, where darkness pools like ink. The temperature plummets, and your suit registers negative ATC. Frost glitters on rock faces, catching stray sunlight like powdered diamonds. Down here, in the stillness, you can almost imagine life hiding, protected from radiation and cold, clinging to traces of moisture trapped in salt. A faint vibration ripples through the ground. Mars quakes, tiny tremors caused by shifting crust. The InSight lander detected them, proving the planet isn't geologically dead after all. It still moves, still breathes a little. Under all that dust, you pause, realizing Mars is both a graveyard and a promise. It's a fossil of planetary youth and a testing ground for humanity's future. Someday, maybe, people will stand here without suits, under domed skies filled with engineered air. The first garden on Mars might grow where nothing has grown for 4 billion years. You look up one last time. Phobos and Deimos, the twin moons, drift silently across the rust-red sky. They look like potatoes, small, misshapen, captured asteroids, but they circle faithfully, casting long shadows over the plains. One day, Phobos will spiral inward and crash into Mars, breaking into a ring that may encircle the planet for millennia. Mars doesn't just orbit, it evolves, slowly, patiently, even in ruin. You rise from the canyon, watching the red world curve beneath you. The thin air fades, and the stars return. Mars glows like a dying ember below, lonely and magnificent. You take one last look, because what comes next isn't rock, or dust, or heat. It's beauty and chaos, wrapped in bands of color. You're heading for Jupiter, the giant that rules them all. Jupiter creeps into view, like a god rising from the void, striped, swirling, and utterly enormous. From afar, it looks painted, its clouds marbled in beige, cream, gold, and rust. But as you draw closer, the illusion breaks. Those colors are storms, monstrous systems of gas and lightning, each wider than entire continents. The first thing that hits you isn't sight, it's scale. Jupiter is so vast it could swallow 1,300 Earths, and yet it's made mostly of hydrogen and helium, the same stuff that fuels stars. You're not really looking at a planet, but a failed sun that never quite caught fire. You feel small again, like a dust mote staring up at a storm. You drift toward the equatorial bands, watching them churn like slow boiling rivers. Winds here can reach 600 kilometers per hour, faster than a hurricane back home. Each stripe marks a jet stream flowing in the opposite direction of its neighbor, an endless tug of war, sculpted by heat, rotation, and chaos. And there it is, the great red spot. Your brain falters trying to process it. A storm so massive it could swallow Earth 3 times over. It's been raging for at least 350 years, maybe longer, though it's slowly shrinking, like a weary beast losing strength. The clouds swirl in hypnotic spirals of peach and crimson, their edges fringed with lightning that never quite fades. Here's your mainstream fact. Jupiter radiates more heat than it receives from the Sunday. Deep inside, gravitational compression squeezes the planet's core, turning potential energy into warmth. That's why its atmosphere dances with motion. It's alive with internal fire. You edge closer, and the colors shift subtly, fading into lavender and cream. Each layer hides another ammonia ice up top, ammonium hydrosulfide below, and perhaps water clouds deep beneath that. But no probe has ever seen the solid surface of Jupiter, because there isn't one. The deeper you go, the denser and hotter it becomes, until hydrogen itself turns metallic under crushing pressure. It's as if the planet turns into a liquid mirror that conducts electricity, fueling its colossal magnetic field. That field, by the way, is terrifying. Jupiter's magnetosphere is the largest structure in the solar system, extending millions of kilometers into space, so huge that if you could see it glowing, it would look bigger than the full moon from Earth. It traps radiation strong enough to fry a spacecraft's electronics within hours. Your shield hums faintly as you enter its influence. Your sensors flare like static. Jupiter's moons start to appear around you, more like a miniature solar system than a set of satellites. There are nearly 100 of them, but 4 stand out, discovered by Galileo in 1610. Io, Europa, Ganymede, and Callisto. You decide to visit the nearest one, drawn by its glow. Io greets you with volcanic fury. Its surface bubbles and cracks, yellow and orange from sulfur deposits, constantly reshaped by eruptions. It's the most volcanically active body in the solar system, thanks to Jupiter's tidal grip stretching and heating it from within. You hover above a lava fountain, soaring dozens of kilometers high. It's beautiful, horrifying, and oddly hypnotic-like watching fireworks on an alien inferno. Quirky tidbit time. Io's thin atmosphere collapses every night. When sunlight fades, the gases freeze onto the surface as frost. Then, when the sun rises, they sublimate back into gas, reforming an atmosphere by breakfast. It's the only moon that literally breathes with the day. You pull back from Io and glide toward Europa, the quiet one. From above, it looks like a smooth ball of ice, laced with dark, spider-like cracks. There's no mountain, no crater, just frozen ocean crust, endlessly shifting. Beneath that shell lies a global ocean, perhaps 100 kilometers deep, kept liquid by heat from tidal flexing. Scientists still argue whether that ocean could harbor life. Maybe it's just sterile brine, or maybe under the crushing ice microbes swim near hydrothermal vents, living off chemical warmth. Europa's surface glows faintly with radiation-induced light, like it's whispering secrets from below. You imagine drilling through, hearing the crack of ancient ice, and seeing alien bioluminescence flicker back. You continue outward to Ganymede, the largest moon in the solar system, even bigger than Mercury. Its surface is a patchwork of cratered rock and bright ridges, and deep inside it hides a magnetic field, the only moon known to have one. Jupiter's magnetosphere meets Ganymede's in a shimmering auroral dance that wraps the poles in blue light. You float there for a moment, watching magnetic curtains ripple silently across the black. Callisto waits farther out, cold and scarred, ancient and untouched. It's like the solar system's memory, its surface unchanged for billions of years. You can almost feel the weight of time pressing down here, the sense that this is where the chaos of creation finally cooled and went still. Your instruments ping as you cross Jupiter's radiation belt again, and you can feel the strain of invisible fire pressing against your shields. Lightning flashes through the planet's upper clouds, streaks hundreds of kilometers long, bright enough to illuminate entire layers of atmosphere. You think about the probes that came before you: Pioneer, Voyager, Galileo, Juno, brave metal travelers that dove into the storm and sent back fragments of wonder. Galileo's final message ended as it plunged into Jupiter's depths, crushed and melted in seconds. Somewhere in that pressure, its atoms are still there, drifting in the metallic hydrogen sea. Scientists still argue about what lies at Jupiter's center. Is there a solid core, a molten soup, or just compressed fluid all the way down? Even the Juno spacecraft's data can't decide. It's one of the great open questions of planetary science, a mystery wrapped in 90% hydrogen and too much gravity to ever touch. You pull away, feeling both awe and relief. Behind you, Jupiter spins slowly, wrapped in storms that will outlive humanity. Its faint auroras glow at the poles, larger than Earth itself, shimmering with radiation from its moons. It's a reminder that beauty can be lethal and that chaos can be mesmerizing. As you turn away, the planet fades into a marbled jewel in the distance. Ahead, Another giant glimmers, a world with rings so delicate they look like whispers of light. You know its name already. Saturn is calling, and it spins in gold. Saturn appears slowly like dawn breaking across the void. At first, you see nothing but a pale shimmer. Then thin lines of gold and silver begin to resolve into rings delicate, impossibly bright, floating like lace spun from starlight. As you draw closer, the sight hits you in the chest. You've seen pictures, sure, but nothing compares to standing before it. It's not just beautiful, it's hypnotic. The rings stretch hundreds of thousands of kilometers, thin as smoke, yet so perfectly aligned you can almost hear them hum. The planet itself glows softly beneath, wrapped in bands of honey and cream. Its clouds move slower than Jupiter's, more graceful, like the whole world is dreaming in pastel. You feel calmer here, as if Saturn's elegance itself radiates serenity through space. Mainstream fact first: Saturn's rings aren't solid. They're billions of particles, ice, rock, and dust, ranging from grains smaller than sand to boulders the size of houses. Each one orbits independently, forming a vast, flat sea of frozen motion. And yet, from afar, they look smooth, seamless, an illusion of unity, built from chaos. Scientists still debate how old the rings really are. For decades, they thought they formed with Saturn itself 4 billion years ago. But new evidence suggests they might be far younger, maybe just 100 million years old. If that's true, they didn't see the dinosaurs. They might vanish again before humanity's story ends. You drift into the rings themselves, and suddenly you're flying through a storm of ice. The sunlight scatters through the particles, making them sparkle like diamonds. It's quiet here, eerily quiet, except for the occasional soft ping of ice brushing your hull. You could stay forever in this frozen ballet, suspended between worlds. Then you look down. The clouds of Saturn roll beneath you, soft and endless. But there's a strange beauty in their orderliness: hexagonal storms at the poles, vast belts, and subtle whirls shaped by jet streams and hidden heat. The hexagon at the North Pole, yes, an actual hexagon, is one of Saturn's strangest features. A storm the size of Earth that somehow forms a near-perfect six-sided shape, rotating endlessly, perfectly symmetrical. Scientists still argue about what holds its shape. Maybe it's standing waves in the atmosphere. Maybe something deeper, more mathematical. Whatever it is, nature just casually solved geometry with a hurricane. Quirky tidbit time. Saturn would float in water. Well, if you could find an ocean big enough, anyway. Its average density is less than that of water, meaning it's basically a giant gas balloon of hydrogen and helium. Not that you'd want to try dunking it. The splash would rewrite physics. As you glide closer, you notice faint streaks crossing the ring's waves and ripples caused by Saturn's moons tugging on the ice. Each moon, from tiny Pan to massive Titan, plays a part in sculpting this cosmic record groove. You fly over the Cassini division, the large gap between the bright A and B rings, carved by the gravitational rhythm of the moon Mimas. The entire system is like a symphony of motion, every particle in perfect time. And then you spot Titan. It hangs like an orange lantern in the distance, shrouded in thick, hazy atmosphere. You steer toward it, drawn by its mystery. Titan is the only moon with a dense atmosphere, mostly nitrogen with a touch of methane. Its surface hides beneath that haze, but radar scans reveal lakes and rivers of liquid methane and ethane, flowing like Earth's water, but under a sky that rains hydrocarbons. You descend through Titan's orange fog, and the light turns syrupy, dim. The air pressure here is higher than Earth's. If it weren't for the cold around -179, you could almost walk without a suit. You land near a lake called Kraken Mare, the largest sea of liquid methane known. It glistens faintly, black and mirror-like. You kneel down and scoop some up. It drips like oil, sluggish and alien. Scientists still argue whether Titan could harbor life. Not life as we know it, but methane-based organisms that use hydrocarbons instead of water. The chemistry seems impossible, but Titan's atmosphere is full of complex organic molecules, precursors to biology. Maybe nature found a different recipe here, one that doesn't need warmth or water, just time. You walk toward the distant horizon, where dunes of dark hydrocarbons ripple like frozen waves. Every sound is muffled, every step slow. Titan feels ancient, patient, as if it's been waiting for someone to listen. A memory flickers. Cassini, the spacecraft that danced through Saturn's system for 13 years. It dove between the planet and its rings, sending home data until its very last second, then plunged into Saturn's atmosphere to avoid contaminating moons like Titan or Enceladus. Its final moments were recorded in faint radio whispers, a goodbye from a machine that watched the giants for us. You lift off again, heading toward Enceladus. It's smaller, colder, brighter, a snowball world gleaming like polished ivory. As you approach, you notice plumes shooting into space from its south pole, geysers of water vapor and ice dust. They glitter in the sunlight, creating a faint halo that feeds Saturn's E-ring. You pass through one of the plumes, and your sensors light up. Salty water, organic molecules, and heat signatures. Beneath Enceladus's icy shell lies a global ocean, warmed by tidal flexing just like Europa's. But unlike Europa, this one's venting into space, an open invitation. It's one of the most promising places in the solar system for life. Maybe tiny microbes swim there right now, illuminated by hydrothermal vents in eternal darkness. You pause and glance back. From this distance, Saturn and its rings look fragile, almost unreal. You realize something profound. Beauty in space is often just physics made visible. Gravity, resonance, temperature, they shape art more perfect than any painting. And yet, Saturn feels melancholic too. Those rings won't last forever. The particles slowly spiral inward, falling like glittering rain into the planet's atmosphere. Someday, the rings will vanish, leaving only memory, a ghost of radiance around a golden world. For now, though, they shimmer, flawless and alive. You drift upward, the rings stretching around you like halos of frozen light. You take one last look, because the next planet isn't gentle or graceful. It's tilted, weird, and the color of sea glass. Uranus waits, spinning sideways into strangeness. Uranus waits in silence, a pale turquoise marble suspended in black. After the golden warmth of Saturn, its color feels like a sigh-cool, distant, melancholy. As you approach, it doesn't roar or shimmer. It just exists, serene and almost featureless, as if someone dimmed the contrast on the universe. But don't be fooled by its calm. Beneath that dreamy calmness, Uranus hides some of the strangest physics in the solar system. You glide closer, and your senses begin to pick up the chill so cold it almost breaks the scale. The average temperature hovers around -224°C, colder even than Neptune at times. That makes Uranus the coldest planet in the solar system, a world where even sunlight feels like a forgotten rumor. You imagine trying to take a nap here, you'd freeze before you even finished your first yawn. Here's your mainstream fact for this leg of the journey. Uranus spins sideways, literally. Its axis is tilted about 98 degrees, meaning it rolls around the sun like a barrel. Scientists think it was knocked over by a colossal collision billions of years ago, possibly with a planet-sized body. That ancient impact not only toppled it, but might also explain its faint rings and bizarre magnetic field. The result is a planet that defies all expectations, half elegance, half cosmic accident. From your vantage point, its rings are faint and dark, like charcoal dust against pale teal clouds. They're nothing like Saturn's thin, shadowy arcs made of radiation-baked ice and rock. You float above them and realize how quiet everything is. Uranus doesn't shout like Jupiter or dazzle like Saturn. It whispers, like the cold side of a dream. The planet's upper atmosphere is made of hydrogen, helium, and methane, the latter giving it that serene blue-green color. Sunlight filters through the methane and scatters in blue, painting the whole world like sea glass under moonlight. Yet, unlike Jupiter or Saturn, Uranus shows almost no visible storms. For years, astronomers thought it was static, lifeless, but infrared scans later revealed dynamic weather deep beneath the calm, a restless heart hidden under a tranquil mask. You descend gently into the upper layers. The clouds are sparse, gauzy, almost non-existent. Beneath them, pressure rises and temperatures soar. Somewhere below, scientists believe, lies a strange ocean, not of water, but of ammonia, and water mixed with methane. It's not liquid like you'd imagine, but a dense, icy slush under immense pressure. Quirky tidbit time. Uranus might literally rain diamonds. Deep inside, where the pressure is millions of times that of Earth's atmosphere, methane molecules break apart. Carbon atoms then compress into crystalline forms, falling toward the core as diamond hail. Imagine an endless storm of gemstones, quietly raining through darkness, each one the size of a pebble, or possibly a boulder. You can't see it, but the idea alone sparkles in your mind. A planet so cold, it burns with invisible beauty. Somewhere down there, glittering ice and diamond hail collide in slow motion, while the whole world rolls through eternity on its side. Scientists still argue about Uranus's magnetic field. It's one of the strangest ever observed. Unlike Earth's or Jupiter's, which align roughly with their rotation axes, Uranus's field is wildly tilted and offset, as if it's generated not from the core, but from turbulent layers closer to the surface. That means its poles wander unpredictably, twisting through space in complex loops. Some models suggest this chaos is why Uranus experiences bizarre, shifting auroras, ghostly arcs of blue and violet light that flicker unpredictably at the edge of darkness. You imagine what a sunset here would look like. During certain seasons, One hemisphere faces the sun continuously for decades, while the other languishes in twilight for the same stretch. Entire generations of hypothetical life, if life could exist here, would live and die without ever seeing a sunrise. Then, as the planet continues to roll, the light would slowly return, glancing through the haze like a ghost remembering its way home. You hover over the terminator line, the twilight boundary between day and night. The edge of Uranus glows faintly, like a neon bruise. You glance at your readouts and see faint traces of lightning deep below. Even here, energy stirs. Even this quiet planet has thunder in its heart. It's easy to overlook Uranus. Even the Voyager 2 spacecraft, the only visitor ever, barely stopped to take pictures as it flew past in 1986. For decades, we've known so little, but that mystery gives it power. There's poetry in its obscurity, in knowing that a giant rolls silently at the edge of sunlight, wrapped in stillness and storms we've never seen. You swing around its moons. There are 27 of them, all named after Shakespearean and Alexander Pope characters: Oberon, Titania, Miranda, Ariel, and Umbriel. Each one is peculiar in its own way. Miranda, for instance, looks like a shattered puzzle, a moon that broke apart and reassembled itself, scarred by cliffs taller than Mount Everest. Ariel gleams brighter, smoother, with hints of ancient ice flows. Titania and Oberon orbit farther out, dark and quiet, their surfaces cratered with eons of frozen history. You glide past Miranda's jagged edge and feel a flicker of unease. Its landscape looks almost impossible, fractured canyons that seem to rise and twist in defiance of gravity. It's as if the moon itself remembers being destroyed and rebuilt. The thought is oddly comforting. Even in space, things fall apart and come back together again. Your instruments record faint whispers of methane and hydrogen trailing behind Uranus, forming a thin, invisible exosphere. You drift upward, past the pale ring plane, and take one last look back. The planet turns slowly, sideways and serene, its glow fading into distance. Scientists still argue why Uranus gives off so little internal heat compared to its fellow giants. Maybe that ancient collision vented its warmth into space. Maybe its core is insulated in strange ways we don't yet understand. Either way, Uranus remains the solar system's introvert, cold, quiet, mysterious, and unbothered. As you leave its gravity, you glance forward. The light from the sun has grown faint, almost too weak to cast shadows. Ahead, a deeper blue gleams in the dark, more vibrant, more turbulent. Neptune, the farthest known planet, where winds roar faster than sound, and the frontier of our solar system begins to blur into eternity. You steady yourself. The cold deepens. The stars thicken. You are about to meet the last of the giants, the keeper of the outer dark. Neptune emerges like a ghost king, cloaked in indigo and wind. From afar, it looks almost serene, just another jewel drifting through the black. But as you get closer, the illusion shatters. The color deepens into electric blue, the kind that seems to hum even in silence, and the planet begins to move beneath your eyes. Not literally, of course, but visually, emotionally. It moves. Bands of clouds rush around the sphere, so fast and violent they almost blur into a single shade of restless motion. You can feel the power even before you reach the atmosphere. Neptune is chaos, wrapped in calm. It's the farthest planet from the Sun, an ice giant in name, but not in temperament. If Uranus is quiet, introverted, and tilted toward dreams, Neptune is its feverish, twin-awake, unpredictable, roaring into the dark. Here's your mainstream fact. Neptune has the fastest winds in the entire solar system. They scream across its surface at over 2,000 kilometers per hour, faster than the speed of sound. If you stood in those winds, not that you could, you'd be ripped apart molecule by molecule before you even realized it. The thought makes you chuckle softly. You probably wouldn't survive this, you murmur to yourself. But what a view it'd be on the way out. As you descend closer, you see streaks and storms painted across the clouds. Ghostly white methane cirrus whipping over cobalt skies. One storm dominates the southern hemisphere. The Great Dark Spot, discovered by Voyager 2 inches 1989. It was a swirling vortex the size of Earth itself. Then, decades later, it simply vanished. And then another appeared nearby. Scientists still argue whether these spots are stable structures or just transient bursts of turbulence. Either way, Neptune's weather changes faster than you can blink on a cosmic scale. The air here is thin and deadly, a cocktail of hydrogen, helium, and methane. That methane gives the planet its vivid color, scattering blue light with almost theatrical exaggeration. Yet beneath the clouds lies something more mysterious. A mantle of icy water, ammonia, and methane, compressed into exotic states. It's not solid, not liquid, something in between. A superinic slush that might conduct electricity like metal. You can almost picture it. An ocean of electric ice swirling under crushing pressure, where atoms lose their minds and flow like ghosts. Quirky tidbit time. Neptune radiates more than twice the energy it receives from the Sun. Despite being so far away, it burns with internal heat, maybe left over from its violent birth, or perhaps due to slow gravitational contraction. In other words, it glows from within, like a candle that refuses to go out. You drift closer to the terminator line where day meets night, and you notice something extraordinary. Faint auroras, flickering like blue-green curtains at the poles. Unlike Earth's, they're not symmetrical or predictable. Neptune's magnetic field is tilted wildly, like Uranus's, and offset from its center. The result is auroras that wander across the planet's surface in strange, shifting arcs. Even in its isolation, Neptune dances. Far below, lightning flickers bright, silent, and quick. It illuminates the upper clouds in ghostly flashes. You imagine being caught in one of those storm's winds so fast they blur sound into nothing. Thunder that never reaches your ears, and light that stutters like breath. There's something humbling about realizing that even at the edge of sunlight, chaos never sleeps. Then, out of the blue haze, a small moon appears, Triton. You steer toward it, because Triton is no ordinary satellite. It's icy, pinkish, and orbits Neptune backward retrograde, meaning it moves opposite the planet's rotation. That's a cosmic red flag. It suggests Triton wasn't born here but captured, likely a former Kuiper Belt object that wandered too close and got trapped by Neptune's gravity. The capture probably destroyed Neptune's original moons long ago, scattering them like debris in the void. You approach Triton's surface and land softly on pale plains covered in nitrogen frost. The temperature here dips below -235°C, cold enough that even air becomes solid. Yet somehow, it isn't dead. As you look closer, you see geysers, plumes of nitrogen gas erupting from beneath the ice, powered by sunlight that barely exists. They rise kilometers high, leaving dark streaks on the surface. Life? Probably not. Activity? Absolutely. Scientists still argue whether Triton hides a subsurface ocean. Its density, its composition, its geysers all hint that it might. If so, even this frozen world could harbor liquid water beneath its shell, kept warm by tidal forces. Life, even here, can't be entirely ruled out. It's strange to think about a whisper of warmth surviving at the solar system's edge. You look up. Neptune looms in the sky, deep blue and distant, its faint rings glimmering like gossamer. The sun, from here, is no longer a blazing disk, it's a bright star, no bigger than a coin, yet still powerful enough to sculpt shadows. You feel the weight of isolation settle over you. You've traveled billions of kilometers from home. Everything you've ever known, every laugh, every breath, every sunrise, is just a speck of light in that faraway point of brilliance. You float for a while, watching the methane frost glitter. Neptune's faint ring arcs cross the sky like translucent whispers, their particles colliding and scattering with slow elegance. You remember something, a quiet phrase from an old astronomer's note. The edge of our solar family isn't the end. It's just the beginning of forever. You smile. The cold doesn't feel so sharp now. Maybe it's the silence. Or maybe it's because you can sense what lies beyond. The Kuiper Belt, the solar system's twilight. A realm of ice, rock, and forgotten relics from creation. Out there, Pluto waits, small but stubborn, still orbiting in dignity even after losing its planetary crown. You take one last look at Neptune's luminous blue and whisper, "You're the storm that dreams in silence." Then you turn outward. The stars ahead are sharper now, the sun dimmer, the dark thicker. You're heading past the last true planet. Toward the edge of everything familiar, you drift past Neptune's outermost ring, and the glow of the planet fades behind you until it's just a sapphire smudge in the distance. Ahead stretches a vast and quiet darkness, the Kuiper Belt. It's strange, this place, neither fully empty nor truly crowded. A cosmic scrapyard where sunlight is weak and shadows last centuries. You're floating through the debris of creation, the leftover shards from when the solar system was still molten and chaotic. You pass icy fragments that glint like shattered glass, some as small as snowflakes, others as wide as mountains. They move slowly, almost lazily, tracing silent ellipses around the sun that will never end. Most of these objects are nameless, unstudied, forgotten, but they hold stories older than Earth itself. You think of them as memories, the solar system's fossils, frozen in time. Then, you spot something familiar ahead, a tiny world, faintly reddish against the black. Pluto, the little wanderer that used to be a planet, then wasn't, then somehow became something more, the ambassador of an entire new class of worlds, the dwarf planets. You approach, and the details sharpen. Pluto's surface is patchwork, golden plains, dark scars, and heart-shaped brightness. The famous heart, officially called Tomba Regio, shines like a frozen symbol of resilience. It's composed largely of nitrogen ice, spread across a basin so wide it could swallow Texas and Oklahoma combined. You land gently at its edge. The ground beneath you is smooth, etched with faint lines that look like veins in marble. Above, the sun is so dim that twilight never fades. The light here is 1,000 times weaker than what you knew on Earth. Yet somehow, it's still enough. A faint haze glows around Pluto, a blue atmosphere of nitrogen and methane that scatters sunlight just right, turning the edges of the world into a soft halo. It's delicate, ephemeral, and heartbreakingly beautiful. You remember the day in 2015 when the New Horizons spacecraft flew past and captured humanity's first close-up look. It had traveled nearly a decade, over 4.8 billion kilometers, just for a few hours of photographs. That mission didn't just reveal a world, it revealed wonder. Because Pluto, as it turns out, isn't just a frozen rock. It's alive in its own slow, silent way. Its surface changes with the seasons. Its ices shift and flow like glaciers. Mountains made of solid water rise like icebergs. There's evidence of possible cryovolcanoes, volcanoes that erupt liquid nitrogen instead of lava. And perhaps, deep beneath its crust, there could be an ocean, liquid, salty, and ancient. Some scientists think it's still there, kept from freezing solid by radioactive heat and the insulating power of its icy shell. You take a step and leave a faint footprint in the nitrogen frost. It won't fade for millions of years. Time moves differently here, not slower or faster, just gentler. Pluto's largest moon, Charon, looms close above you, locked in a perpetual embrace. The two worlds orbit each other like a slow dance, so close that if you stood on Pluto's surface, Charon would never move across the sky. It would hang there forever, fixed, massive, silent. You look up at it now, a cratered, grey sphere with strange canyons and deep scars. Its equator bears a dark belt of reddish dust, thought to be material stolen from Pluto's escaping atmosphere. Two worlds, exchanging breath across the void. There's something poetic about it. A planet and its moon, bound not by fire or light, but by loss. Cast away from the center, demoted, redefined, yet still dancing in each other's gravity. You smile and whisper, titles don't change what you are, because in truth, Pluto never stopped being a planet. Not to those who remember, wonder. As you leave, you glance back once more, watching the twin world shrink. It feels less like you're leaving, and more like you're being released, set free to drift into even darker territory. Beyond Pluto, the Kuiper Belt stretches for billions of kilometers more. It's a realm of small, frozen bodies, Eris, Haumea, Makemake, and Sedna, each with their own quirks and mysteries. Eris, for instance, is slightly smaller than Pluto, but more massive, bright enough to outshine it. It was Eris' discovery, ironically, that forced astronomers to rethink the definition of a planet the moment Pluto lost its crown. Haumea spins so fast it's stretched into an egg shape, and it's ringed by faint, icy debris. Makemake glows with a reddish tint, like rust under starlight. And Sedna? Sedna is different. Its orbit stretches so far from the Sun that it takes more than 11,000 years to complete a single revolution. When it reaches aphelion, its farthest point, it will be over 130 billion kilometers away. You imagine watching Sedna crawl through the black, moving so slowly that a human lifetime wouldn't even mark a fraction of its journey. It's almost poetic, a world that drifts through millennia, alone, untouched, unlit. Yet you can't help but feel that these outer objects aren't random. They're clues, whispers from the early days, telling us about how planets formed, how they were scattered, and what might still be lurking out there in the dark. Because even beyond Sedna, scientists suspect there might be something else, something massive, a phantom planet, Planet 9. You glance forward, squinting into the void. Could there really be another giant world out there, far beyond Neptune, influencing the orbits of these distant objects? Its gravity seems to tug at them in unison, as if pulling invisible strings. No one's seen it yet, but the mathematics are persuasive. It's thrilling, and a little eerie, to think that a hidden planet could still be part of our solar system, unseen, unconfirmed, waiting in the black. And then it hits you. The further you go, the more the familiar fades. The sun is now just another star among billions, indistinguishable from the rest. You've reached the boundary where home becomes concept, not location. Still, you keep drifting outward through the last wisps of the Kuiper Belt, toward the region where the solar system begins to dissolve into the interstellar medium. Ahead lies the Oort cloud, the vast sphere of icy bodies that marks the true edge of the sun's domain. You exhale slowly, the sound barely audible in the silence. The stars seem sharper now, closer, hungrier. You're about to leave the solar system not just in theory, but in soul. And somewhere behind you, a tiny blue world still spins, unaware that its traveler is nearly free. You pass the last of the Kuiper Belt wanderers, and space becomes thinner, emptier than empty, darker than any night you've known. But even here, the sun still reaches you, faint and distant, a small coin of light with a warmth that takes hours to arrive. And now, after all this drifting, you turn back toward it. The true heart of everything you've seen, the engine, the origin, the steady heartbeat that has kept this entire system alive for over 4.5 billion years. You're falling toward the Sunday. Not literally, of course. If you were, you'd vaporize long before you got close. But in your mind, you can glide through the emptiness, closer and closer, until that pinprick of gold becomes an overwhelming roar. At this distance, you can finally feel the scale. The sun isn't just a ball of fire, it's the fire. A sphere of plasma, 1.4 million kilometers across. You could fit more than 1 million Earths inside it, and still have room to spare. Its light, though it looks steady to your eyes, flickers and writhes on atomic timescales. Beneath its surface, every second, over 600 million tons of hydrogen are fused into helium. That fusion releases enough energy to power civilization for millions of years. Yet the sun has been doing it effortlessly since before Earth existed. Scientists call the sun a G-type, main sequence star, a plain, middle-aged star by galactic standards. But to you, watching it up close, there's nothing ordinary about it. You see the granular texture of its photosphere, each cell a churning plume of plasma the size of Texas. Magnetic fields twist and snap in arcs that stretch hundreds of thousands of kilometers high. You notice flares bursting outward, massive tongues of fire ejecting loops of charged particles into space. If one of those eruptions pointed directly at Earth, it could fry satellites, overload power grids, and paint the skies with auroras brighter than any neon city. And yet, the same sun that can disrupt technology also nurtures life. Its warmth sustains every leaf, every wave, every breath you've ever taken. Without it, Earth would be an icy marble drifting silently through the dark. There's a comforting irony in that balance, how something so dangerous can also be so essential. It's a cosmic version of that "don't get too close to the stove" lesson your parents warned you about. You drift closer still, to where the sun's corona unfurls into space, a ghostly halo of plasma, millions of degrees hot. It's a mystery even now. Scientists still argue whether magnetic reconnection or wave heating causes that incredible temperature difference between the corona and the lower layers. It's one of those unsolved puzzles that keeps solar physicists up at night. And the corona doesn't just shimmer, it breathes. Streams of charged particles flow outward, carried by the solar wind. They stretch across billions of kilometers, shaping planetary magnetospheres and carving trails of light when they collide with atmospheres. Earth's auroras, those dancing veils of green and purple, are born from these invisible rivers of energy. You remember the first time you saw an aurora, maybe on a cold night in the far north, when the sky suddenly rippled like silk. You had no idea you were watching a direct handshake between your planet and the Sunday. Every color, every flicker, was the language of magnetism. From this distance, you can also sense how delicately the sun keeps everything in motion. Its gravity holds the planets in perfect clockwork rhythm. Tiny variations, just a whisper of mass loss or magnetic drift, can alter orbits over eons. It's the universe's most patient puppeteer. But it's not eternal. Nothing is. One day, billions of years from now, this star will begin to change. As its hydrogen runs low, the fusion reactions at its core will falter, forcing it to swell into a red giant. It will expand past Mercury's orbit, perhaps even consuming Venus, and maybe, if Earth is unlucky, our world too. It's hard to picture something so warm, so steady, turning monstrous. But it's part of the cycle. Eventually, the outer layers will drift away, forming a glowing nebula that will scatter elements into space: carbon, oxygen, iron, gold, the same stuff that will seed new stars, new planets, maybe new lives. You, me, everything you've ever touched, all of it once came from stars like this. That's not poetry. That's chemistry. Star stuff, as Carl Sagan called it. And maybe that's why the sun feels like home, not just because it warms us, but because, in a sense, it's our ancestor. You can't help but think about the spacecraft we've sent to study it. The Parker Solar Probe, for example, darting closer to the sun than any object ever built by humans. It's basically flying through fire, shielded by carbon composite material designed to withstand temperatures over 1,400 C. Every orbit brings it nearer to the corona, where it tastes the solar wind directly. Parker's data has already revealed unexpected things: tiny magnetic switchbacks that twist the solar wind, miniature jets, and turbulence that no one predicted. It turns out, even our star still surprises us. There's a kind of humility in that realization. We orbit this thing every year, depend on it for our survival, and yet we still don't fully understand it. The sun hums quietly to itself, resonating with seismic waves that ripple across its surface. We can listen to those vibrations using helioseismology, mapping the interior structure of the star like a doctor using ultrasound on a patient. Each note tells us something new about the layers below. It's music of the plasma kind, and if you could somehow amplify it, the sound would be deep and continuous, like a slow cosmic heartbeat. You feel that hum now, vibrating gently through the vacuum, even though there's no air to carry it. You imagine that each pulse is time itself, keeping rhythm with the slow spin of the solar system. And when you finally turn away, you realize how everything connects: the heat that makes the winds of Neptune, the gravity that steadies Pluto's orbit, the light that paints Earth's skies. All of it starts here. The sun doesn't just power the solar system, it defines it. Everything else is simply dancing to its rhythm. You drift backward again, feeling that warmth fade, the glow shrinking behind you until it's just another glimmer in a sea of stars. You're leaving not just a star, but an entire origin story. Somewhere, deep inside your mind, you can still hear that hum, the heartbeat of home. You drift outward again slowly, softly past the planets, past their moons and faint rings, past the ghostly halo of comets that orbit the sun from afar. The light grows weaker, with every million kilometers, fading into a thin, grey mist. You've crossed the frontier into the Oort cloud, the vastest and quietest realm of all. It's not a disk like the Kuiper belt. It's a sphere, a hollow shell of icy fragments, surrounding everything you've visited so far, a shimmering bubble that marks the edge of the sun's reach. Each fragment here is ancient, older than life itself. You can barely see them, faint motes that glint only when they catch the sun's light at the right angle. Some are frozen lumps of rock and ammonia, others are relics of long-lost comets, still waiting for the day their orbits will carry them inward again after millions of years. You float between them, feeling as though you're drifting through a cathedral made of glass dust. The silence is absolute. No warmth, no sound, not even the faint murmur of the solar wind. Out here, even time seems to have fallen asleep. Scientists still argue whether the Oort cloud truly forms a perfect sphere or a stretched halo, whether it's a single structure or a series of overlapping shells. It's one of those cosmic riddles we can only study indirectly, by watching the paths of comets as they swoop inward, their icy bodies igniting into tails of fire as they greet the sun once more. You remember some of their names: Halley, Hale-Bopp, Neowise, messengers from this very place, streaking across Earth's sky for just a few nights before returning to the dark. Every comet you've ever seen is a brief hello from this invisible frontier. And still, beyond this cloud, the solar system finally ends. Or maybe it just fades. There's no line, no boundary marker, no final orbit. The sun's gravity slowly weakens until it becomes indistinguishable from the pull of other stars. You've reached the interstellar medium, the true void between suns. You glance back. The solar system now appears as a pale sphere of light, its planets invisible, its star barely brighter than the others around it. Voyager 1, humanity's farthest traveler, is out here somewhere too. You imagine it drifting silently, its golden record still attached our message in a bottle to anyone or anything that might one day find it. The record carries greetings in 55 languages, sounds of Earth's oceans, laughter, music, thunder. Carl Sagan once said that launching it was like casting a note into the cosmic ocean, hoping that someone might read it one day and know that we existed. You wonder if that note is still playing in some faint corner of space, whispering our story into the void. And maybe that's what makes this moment so profound. You're not just standing at the edge of the solar system. You're standing at the edge of human imagination. Everything we've ever built, everything we've ever dreamed, is somewhere behind you now, bound to that distant glow. Ahead lies interstellar space, a darkness so complete that it feels alive. The nearest star, Proxima Centauri, is still over 4 light-years away. That's 40 trillion kilometers. If Voyager keeps going, it won't reach that star for another 75,000 years. You let that number roll over in your mind, heavy and soft. The scale is impossible, but that's what makes it beautiful, because somehow you're part of it. Every atom in your body, every thought, every heartbeat is made of the same matter that once burned in the cores of stars. You're not apart from the universe. You are the universe just briefly awake enough to notice itself. You take one last look back. The sun glimmers faintly, a tiny ember wrapped in velvet black. Around it, invisible threads of gravity still hum, holding its worlds in perfect balance. Mercury still bakes. Venus still spins backward in its slow agony. Earth still turns, blue and alive. Jupiter still roars. Saturn still shimmers. Neptune still howls. And you? You just float, weightless, calm, timeless. There's something deeply soothing about realizing how small you are, not in a way that diminishes you, but in a way that frees you. The worries of the day shrink beside the orbit of a moon. The rush of a year dissolves against the age of a comet. Even your heartbeat seems to fall in rhythm with the turning of worlds. The solar system breathes around you, vast and unbothered. And now, your breathing slows. The stars don't move anymore, they just shimmer, steady and patient. You can almost feel the temperature of space. Not cold exactly, but still, a stillness that holds everything, everywhere. If you listen closely, there's a rhythm beneath it all. Maybe it's the echo of the sun's fusion, or the magnetic song of Jupiter, or maybe it's just your pulse, syncing with the quiet universe. Let it guide you downward. Each breath becomes slower, deeper, softer. Every sound you've imagined, the rumble of solar flares, the whisper of icy dust, the gentle hum of orbiting moons, begins to fade into one long exhale. You think of how far you've traveled tonight. From the molten birth of planets to the faint edge of sunlight, from chaos to calm. Every fragment, every spark, every drifting stone had a role. Even now, their stories continue in silence. And as you rest here, at the very edge of the sun's embrace, you realize there's no real border between space and sleep. Both are vast. Both are silent. Both are places where thoughts dissolve into motionless light. So let go. Let gravity lose its claim on you. Let the last traces of warmth slip gently through your fingers. You've seen everything tonight, from Mercury's glow to Pluto's heart, from Saturn's rings to the Oort cloud's shimmer. The solar system is smaller now, tucked behind your eyelids, humming like a lullaby. It's time to drift, to float through the quiet, to dream among the stars. Good night, traveler, and sweet dreams.